colleague, Professor Helen. We work in the Center for Research in Computing at the Open University, and we're working on a project called Motivating Gen, which I will talk a little bit more about later in the talk. But I just wanted to point out that our colleagues, we have colleagues also at the University of Exeter, and we are working with funding provided by the National Cyber Security Center. Okay, today we're going to talk about secure code development in practice. So, security really is everywhere these days. You can't open a device, or as I still do, a newspaper, without seeing something about a compromise or fallout from a compromise. And often these are connected to software, because software really is everywhere these days. Even within kids' magazines like this one, coding is big, software is big. This is Okido, I don't know if you guys have seen it, and this particular issue is all about coding. But it's really, really interesting because the message that kids are getting right now is that security is also important. If you take a look at a lot of the articles, the activities in this magazine, they're about making secret codes. They're about making messages that you can keep private or hidden. So today, somehow, the stakes for security seem higher. There seems to be more fear around the topic. Before, at the turn of the century, I remember, security was about credit cards and worry about putting your credit card number into the computer, or worry about making a big ticket purchase, right? But now, as this article from The Guardian shows, security means much, much more. It's come to mean something about our bodies, and the messages that we're sending to our kids is coming to mean something about ourselves. It's important to us. What can we say about security? Well, good security principles and practices, they're out there. Yeah? They have been for a while. They explain what should be done, for example, by providing defense in depth for a system, what should not be done, and a classic example of that is security through obscurity. And there's relatively good awareness of them, even in moms, right? But also in developers. So we can also say that most security vulnerabilities are preventable. And I don't think for this argument that we need to look farther than the work of the OS group. Probably most of you are familiar with them, or some of you may be familiar with them. They provided 3 top 10 lists, one in 2010, one in 2013, and the most recent one in 2017, providing a clear set of instructions for developers so that they can recognize vulnerabilities in software, they can understand the risks associated with the code that they're writing or certain features of their code, and so that they can mitigate problems. And the work of the OS group is widely supported in industry, web courses, webinars, articles. I don't know a huge amount about security, but even I know about OS. So what's the problem? We have all of this information. We know what needs to be done. Well, not all software developers use secure practices or use them effectively. And that's a bit of a generalization. Right? Some are using tools well and taking on the task of security and secure code writing. Some are trying, but getting it wrong some of the time. And then there are others who don't seem to appear to be trying very much at all. This is surprising to us because in the main, given the existing foundational work, it doesn't make sense that developers haven't embraced secure coding as a matter of course. We don't really understand why that is. We do, however, know a few things about what motivates developers on the job. And for this, I really should point to my esteemed colleague, Helen, who's done work for a number of years looking into what motivates developers, what gets them excited when they're at work, and what doesn't. On the flip side, what doesn't really turn them on. Most recently, she's been, with some colleagues, she's published a paper in a journal looking at the notions of engagement and satisfaction among developers as being important drivers of work. But prior to that research, we already know a few things. Developers like to learn. They're motivated to learn new technologies. They like to identify with their tasks. And in the work that we've done in field studies, project completions are reported to be among the hallmarks of individual experience. If you ask a developer to look back over their career and tell you what it was that really sticks out in their mind as being good, it's finishing the big project. It's doing something that took a long time, maybe challenged in ways that they hadn't been challenged before, let them learn, and then seeing it to completion. They like to learn, but they don't necessarily like to learn. For those of you who are developers, you'll probably nod your head at this, I hope, by studying manuals or reading documentation. Instead, we have found that community matters to developers quite a bit. They like to engage in peer-to-peer interactions and observations, and they really want to feel a sense of belonging. The sense of community has produced lasting cultural changes within the wider development community. As you know, I only need to say the word agile, or for those of us who are a little older, object-oriented programming. These were big changes that came about through the software development community. So community matters, it really does. So we know that developers like to learn. We know that they like to work together. We also have, on the other side, all of this security information out there, practices out there. And we're asking in our larger research project, what motivates developers to adopt security practices and technologies? And how can we help them engage with security on the job? And the exercise that we're going to go through next is focused on this second part. How can we developers engage with security? I think that is we're starting to have the sense that that's really important. It's not about the text. It's not about the checklist. It's not about the guidelines and the principles. It's about helping them connect to this. So, okay. Let's look at security again from a different perspective. Security wears many, many hats. There are many, many ways that we can answer the question, what is security? One way to do that is by looking at some existing research that has developed models or methods to analyze and assess security within computing contexts. That's obviously what we're dealing with. We're not dealing with physical security. So on this slide, I have three such models. So over here, we'll start here. We have the CIA model. I don't know if you guys are familiar with this. And CIA stands for confidentiality, integrity, and availability. And this model is used within information security to determine what is important about information, what we want for our information. We want it to be confidential. This is a pretty simple model. We want it to be readable by us. We want it to be private to us. We also want it to have integrity. We want to know that that information is consistent and pure, uncorrupted. And finally, we want it to be available when we want it. We can also think about security in terms of attacks. We can take a defensive approach, and that's what, that one. And that's what this model over here shows. This is an example of an attack tree. I pulled it from Schneier's website. And this method of looking at security within software really allows you to make a map of ill intent or aims, the ways that an attack or a threat might be carried out. It lets you really, it's designed to sort of help developers or security specialists think about how an attack might be done and what might be done in the context of a particular system. And then the final way down here that we might think about security is in terms of vulnerabilities or weaknesses. In systems, in software, what is it that makes it easy to attack? What is the prevalence of that weakness? How might we detect it, and what would be the technical or business impacts? So we have some ideas from this about what security is, right? It's about it, and maybe about what developers need to be doing, right? They need to be defenders. Perhaps they need to be knights, or maybe they need to be humble, right? They need to be thinking about weaknesses in what they do. But there's nothing here necessarily. Some of the detail of these methods will be applicable to particular situations, but it might not necessarily connect the developer to it. And the problem of engagement is recognized among security researchers. How can we bring people into the field of security who aren't specialists? How can we make them engage and care about it? One way that this has been explored in the last few years is through games of various kinds. Often they have cards, they're played at a table, they're meant to be played by groups. The ones that I've shown up here are developed by academics, but I have also in the last year seen a few that are coming out of industry or that provide new ways to talk about threat modeling or other things like that. But I'll just talk through a few of these examples. So on the left, we have decisions and disruptions. This is a game that was developed by a colleague of ours who was working at Lancaster, now he's at Bristol. And I don't, let's see, I have to really look. Let's see. It's a role-playing game. Ooh. It's referred to as D&D. It involves cards and Lego. So you can see the Lego there in the picture. And with the series of cards, players can work together through challenges, scenarios of keeping a utilities company safe, right? So it's a chance for them to sort of play with this idea. This is a defensive approach. But it highlights some of the value that researchers and I think industrial professionals see in using play to raise awareness about security. It's informal. It's applicable in a number of contexts with people who have varying levels of experience with security, maybe varying levels of interest in security. And the point that I think is quite important is that it's social, it's interactive, and it's lightweight. This isn't about certification. Somebody's not going to sit down and play D&D and walk away certified. But they might walk away curious. They might walk away wanting to know more. Okay, so the second example that we have here, these are called security cards. They were developed at the University of Washington, and they were designed to sort of help developers think about the human impact and the motivation, resources, and methods that attackers might use. So again, taking a sort of defensive approach towards security in that the developers are being asked to think about attackers, but asking them to think about other aspects. What is it that they, in a slightly softer way, perhaps than Schneier's attack trees, what are their motivations? What are their resources? And what impact are their actions going to have on humans? When we found this, I was quite excited, and I thought, oh, well, that's quite interesting. Maybe we can use that. But I think, again, though this can be used with developers or students who are working on a system, it's still sort of keeping security away. You know, something is going to come from outside into what we're doing. It's not placing the developer at the center of what they do, which is make software. So we looked into this third set of cards here. These are visioning cards, and I have them here. You can come and have a look at them afterwards. This is 3 that I put together. This is an example of one. The researchers who developed the security cards worked with another set of researchers who are very interested in value-sensitive design. And value-sensitive design is interested in helping designers of technology sort of expand their thinking about the immediate effects beyond the immediate effects toward users of what they're building. And this appealed to me for two reasons. For the first reason, it places the center of focus on the activity at hand. Designers are designing, so these cards are intended to help them in that process while they're envisioning the product that will be built. But I wondered if something similar couldn't be applied to developers who are developing, who are making software. And then because this is interested in values, like the security cards, it's looking at stakeholders, it's looking at impact, it's looking at time, but it's also considering how those touch on human values that might be important to us. And I think that this is an important moment for security. We've spent a lot of time, we've worked out a lot of things that we think that should be done, and at the same time, the stakes for it are getting quite high. So this is a moment when developers, I think, they need to be given a stake in security and giving them sort of conceptual tools to think about security might be one way, and talk about security might be one way to give them that stake. Okay. So for basically the rest of the talk, we are going to work through the same case that we did this summer. We were also at the SPA conference this past summer, and we did a workshop, a 90-minute workshop, I think, and we had all of the people in the room basically do work for us. So we've kind of reconfigured that because I think the value in the approach that we are investigating as a part of our research project is in interaction. It is in the social aspect of working through something related to security. So you'll have to bear with me just a moment as I reconfigure how we did this. So the way it's going to work is this. We're going to go through two long phases. I'm going to be your memex today. I'm going to give you the report of a compromise that was widely reported in the media. And hopefully I'll give you enough detail that you'll be able to answer some questions for me. Because this is being recorded, it's really great if you can get excited and scream yay or nay. The first two questions will be yes or no. But if you feel shy, you can raise your hand. And then we'll take an assessment, move on to the next question. And then we'll have a little bit of discussion at the end of that. In the discussion period, we're going to ask you to work with the people at your table, talk for a few minutes on around a particular question, and then feedback some information to us. And then Amit will be really, really happy if you do that so that the recording doesn't have super, super long gaps with crickets. Okay, we'll do that once, we'll do that twice, and then we'll wrap up with a little bit of a discussion about where responsibility for secure code lies. I've given you the big reveal at the end there. I'd kind of like you to keep that in mind as you work through this. Where does the responsibility for secure code lie? Does it lie in tools? Or does it lie in the developers? Should they be responsible for thinking about it all the time? I don't want answers yet. We'll come back to that. Okay, so, and on the next screen and one other screen, there will be a URL. So if I'm not giving you enough information, you are welcome to go and look up the report yourself through the URL, and you can fill in the blanks. So we're going to talk about a compromise made in connection with the open source project Handbrake. Are you guys familiar with Handbrake? Yes? No? No? Okay. It's a encoding tool. So the idea is that you can take a file that's encoded in one format, turn it into a different encoding, and it's commonly used to swap files between operating systems. So you might take an audio file that was created on a Windows machine and turn it into something that you can use on a Mac. Okay. So I use a Mac. I have used Handbrake in the past. So I heard about this compromise. I stumbled on it on the Ars Technica website. I saw, if you installed Handbrake on your Mac, your computer might be hosed. That's interesting. What does that mean? Luckily, I have a relatively new computer, so I don't have Handbrake on my computer right now. but I was curious enough to keep looking into it. And I think that that's probably true for a lot of developers and a lot of us right now in our own life. How do we find out about these things? They come up in the feed all the time. So I learned about it here. This came up around the same time, within the same time frame. The BBC covered it. They said, oh, an app maker's code was stolen in a malware attack. Okay. I was sitting at the desk, eating my sandwich. Yeah, after I just done a big commit. You might have learned about it here on Reddit. They also covered it. Handbrake for Mac Mirror had an infected version of Handbrake. So we're starting to get a few clues about what might have gone on. But really, for the purposes of the exercise today, we're going to look at the report that was made by the project itself. As I said, here's the URL down here, if you want to look it up. But otherwise, let's just try and discover this together. Let's see if we can. I don't know if you can read this, so I'll try and point out things that you can see. So this is Handbrake. We've talked about what that software is. We know that this post is actually made by Handbrake because we've got a pineapple here and a pineapple there. So this is official. Right? When was this made? This was made on Saturday, May 6th, 2017. And above the fold, they tell us anyone who has downloaded Handbrake on a Mac between the 2nd of May and the 6th of May needs to verify the checksum of the file before running it. Okay, so we know this is only affecting Mac users. We know that there's a time frame here that's important, that was crucial. And anyone who downloaded it really needs to really check those sums. I don't usually check the sums. You know, I should, but I don't. Okay, they also say here, anyone who's installed Handbrake for Mac needs to verify that their system is not infected with a Trojan. So that opens it up to anyone. Maybe not me because I have a new computer, but anyone who's got it on a machine needs to look for a Trojan. We know that the malware is a Trojan. And we learn here that you have a 50-50 chance if you've downloaded Handbrake during this period. So in that blurb, we're seeing that not all of their servers were affected. And below the fold, they tell us a few more things. So if you want to check your system, you think you might have been infected, you need to look for a process called activity agent in the OS X activity monitor. As they said before, you need to check those sums, right? They give a little more detail, but not too much. The Trojan is a new variant of OS X Proton. I don't know if you guys are familiar with that. It's been out there for a while. And then if you want to recover from this, you need to remove a number of property files and infected apps because there would have been more than one installed in various locations in various crazy folders on your machine. And you need to change all of your passwords in OS X, Keychain, and in your browsers. Okay, so this is an incident that happened. Here's a summary of some of the things that I shared with you, hopefully all of them. And now we're going to have a couple of questions. What do you guys think? Is this an unusual incident? You can raise your hand if you're feeling shy. Yes, you think it was unusual? No? No, you don't. You think it was not unusual. So it happens. Yeah, it happens often. Okay. So moving on. Do you think it's likely to happen again? Yeah. Okay. All right. Okay. Now we're going to break. I'm going to have you guys work together. I don't know if you're right or wrong, but it's interesting to know that you think it's not unusual. It will happen again. I'd like you to meet and greet and talk for a few minutes about who you think might have been affected by this incident.
We talked about quite a few things. Some of the obvious ones, the users that are affected by it, but also the users that aren't affected because maybe their confidence in the practices of developers would also be impacted, so they might choose no longer to use it, even if they weren't affected. The developers themselves, because unless there's intent to cause harm, I don't think anybody wants to cause harm, so that might affect their sort of confidence and the brand's image at the back of that. And then I think this is open source, so maybe it affects the open source community and the confidence in the open source community. So there's quite a few different vectors.
Yeah, wow.
I'll pass it on to everybody else.
Yeah, that's great. Anyone else have anything? It seems like a pretty good summary. Did you have something? No?
Well, people were talking a lot among themselves. Maybe it's a question of daring to speak out.
Which is fine. That's totally fine. You weren't expecting to have to do this today. That was a really nice summary. Thank you. Yeah, okay, so you pointed out that there were lots of people, and you mentioned a couple of times confidence, right? So confidence in the product, Handbrake, confidence among the developers. I assume you meant the developers who made Handbrake, right? And in the broader user community in open source and in this particular. So, okay, then let's move on. Let's move on to the next part of this. Okay, so now we're going to look at another point of view on the same incident, the same security incident that we just looked at. Again, for those who wish, there is a URL down below. I shall narrate the case for you a little bit, but I might, hopefully, I might miss some points. This one's a longer one, several pages long, so we'll get through it slowly together. Okay, so this post came out May 17th, 2017, my brother's birthday, a little bit after the window of time that we know that this incident took place. So they said between the 2nd and the 6th, and now it's the 17th. This is from the Panic blog. I don't know if you guys are familiar with Panic. This is a software company. Have any of you heard of it? Yes, no. Okay. They make, I knew about them and then I forgot about them, but they've been around for a while. They make software for Macs. I think they've got a suite of products out now. One of them is an editing tool. They've got an FTP transfer tool. They've got an SSH client. So they're really interested in supporting Mac users. This post is called, this is really exciting. I actually stumbled on this in my journey as well. The Case of the Stolen Source Code. And it was written by a fellow called Stephen. Okay. So here's the story. Stephen wrote that had been nagging him for some time to install an update, and he finally decided, for whatever reason, to do the update. And he notes that he breezed right through, and in retrospect, so looking back, sketchy authentication dialogue without stopping to wonder why. And it turns out that in the process of doing this, he hit the window. He had the misfortune to hit that window. He hit the download server that had been compromised at Handbrake's. And he downloaded and installed a version of Handbrake that had the Trojan, the Proton Trojan in it. So, what did they do? What was that Trojan used to do? So they took his Git credentials and they used them to clone several of the source code repositories. So these are the source code repositories at Panic, the company that he works for. And they knew that this had happened because they also got a ransom note from the attacker demanding a large Bitcoin ransom in order to prevent the release of the source code. What did Panic do? What did the company do? Obviously, they did the things that were listed in the report of the compromise that they needed to do. They took the Mac out of commission, they changed all the passwords, they rotated the relevant secret keys, and then they began a process of forensics, combing through logs. I think that this involved someone named John. So John and Stephen worked together. I don't know exactly what role John had. Combing through logs to try to determine the extent of what had been accessed. And they did some other things too. They sought some help from the Apple security team so that they could make sure that any compromised versions of the Panic software would be flagged by the Apple Store and taken down. They made a call to the FBI because they said it involved a ransom. And they wrote this blog post. Stephen sat down and wrote this blog post for the customer base, explaining what happened and what they've done. So what was the impact of this? Well, Luckily, there was no indication of any access to customer information or the synced data. I think some of their apps support syncing data. And there was no indication that the web server was compromised. Okay, so that's good. You know, whew. What was the impact for Stephen? He tells us a lot of things in this blog post. He says, I feel like a monumental idiot for having fallen for this. He recognizes that the evidence was obvious when he looked back on what he'd done. And, you know, I think we all know this, it's almost, you know, it should be put above all of our desks. No matter how experienced you might be, mistakes are easily made. Apparently, at Panic, they sat down after this happened and had a group meeting to talk about what this really meant. What is the impact for the company? And the conclusion that they came to, surprisingly for Stephen at least, was someone has a bunch of our source code, but does it really matter? So the company together came to the conclusion, well, look, if someone wants to steal our code and reverse engineer it and mess with it and send it out, they can already do that. Right? It's already a possibility for them to do it to some extent. But they also said, our code is moving, it's changing. The things that they got access to are already out of date, and they're only going to be more and more out of date as time goes on. Nonetheless, Stephen says, oh, I hate that this happened, and I kick myself every day for not paying attention to what I was doing. So, we see a very different side to this story. And we're going to do a little Q&A again. We're going to start this time with a discussion. On your tables, you have a series of cards. These are value cards. So you've got 2 or 3. I'm holding hedonism. I don't know what you have. And we'd like you to take, again, about 5 minutes to work through which values from your table you think figure into this case that we've just heard about. Now, you can associate these values with the first part of the story that you heard, or the second part of the story. You have freedom to do whatever you wish. And then we'll talk about it again afterwards. All right, so you guys did a great job. I'm going to turn it back over to you in a second. What I'd like each table to do is to choose one of the values and hold up the card for me. That's how we're going to break into this back and forth. Hold up the card you think applies the most, applies the least. I don't know. We'll walk around. We'll find out what to do with them. But hold them up. Stimulation. I don't remember what stimulation is defined as.
It's exactly not can change.
Ah, that's the one that applies the most to this case.
Well, if you look from the hacker side.
From the hacker side. Okay, good. That's good to know. Show me another one.
Humility.
Humility. Okay, and what does it say about humility? I don't remember.
It says, recognizing one's insignificance in the larger scheme of things.
Okay. And are you thinking of Stephen there?
Yes.
Felt like an idiot.
Yeah, he did. Yeah, he did, poor guy.
No.
Yeah, okay. Sure. Oh, this is getting exciting. Can you guys hear me? Yeah. Okay. So here we go. Power.
Yeah, as the least significant.
As the least significant. Okay.
So it says here, power, exercising control over people, control of material and social resources, which initially we might be associated with the hacker, but then we thought, well, actually, the company, the individual has self-direction. They don't actually have to give away control to these people. We can, through our own actions, we can maintain control.
So the company was able to maintain control. They kept the power.
Yeah, or if it never happened in the first place.
Right. I see. Okay, interesting. Okay, and anyone else? Who else?
Tamara, it's also worth capturing what they are saying.
Okay, yeah. Humility again.
Yeah, most significant for all of us, really.
Right. Yeah.
Most difficult thing to achieve.
Okay. I can't see back there. Tradition. Why?
I think in the victim and the company view, they were resilient, they kept cultural traditions, It came to a company rules, it was not like on the fire or something.
Okay.
And they were able to, and if the victim had come through the steps of the software, you wouldn't have been affected. So the thing traditionally was
Okay.
if he had.
If he had.
Yeah.
And that tradition is kind of bigger than just his company, right?
Yes,
That's,
yes.
it's kind of a software tradition.
Yeah.
Yeah, and security maybe.
Security, yeah.
Interesting, okay.
So here, you're using the word tradition in the sense of being methodical and maintaining that method despite the fact.
Right, that's interesting, okay. Do we have any more, or are we feeling shy and too tired? What's that one? What's that orange one?
It's just self-direction.
Self-direction, okay. Right, okay.
So I think the most affected by this would be the person who feels responsible for letting it happen, and it affects in a negative or less it brings in some less motivation or makes them feel less valued
Okay,
because of a simple misread of something, or so I think that has a bigger impact.
I see, yes, okay. Interesting. Okay, and do you want to tell us?
Yeah, was it self-direction?
Yeah.
Yeah, we had the same. But I think our take was a bit different, wasn't it? I think we thought that it was the person's choice to do the update, so they had a certain amount of responsibility.
Yeah.
But then they determined their action was a problem, and so then they've gone to report it straight away rather than being embarrassed.
And keeping it, right, interesting. Okay. Do you want to?
No, it doesn't.
Okay. You don't have to, it's all voluntary.
Wait for conformity, compliance with rules, laws and formal obligations, so they had an obligation to their customers as well.
Right.
So they did release the information and they actually sought out the help of the app security team, the FBI and things, so they knew what they were meant to be doing as well.
Right. Okay. Wow, okay, so, okay. So, you guys all chose different things. Like, what can we take from that? I guess it means that a lot of value came into play for this particular incident, and they affected a lot of different people in different ways. That's helpful for us. We chose this particular set of values. They come out of a piece of research that actually makes some motivational assertions about the values that have been identified. So, and those assertions are sort of in the descriptions of the values themselves. And it's important to the research project that we're working on because we're trying to eventually say, we know some things about what motivates developers, but what can we say about motivating developers in the sense of security, in relation to security? How can we get them to think more about that? And so I think this is quite promising. It's an interesting format to gather the feedback from. So we've done quite a bit of talking, but we still have time. So I want to come back to this initial question that I opened the case with. One thing that I and my colleagues have been wondering quite a bit about as we progress on this project is, where does responsibility for secure code really lie? When we look at research produced by information security researchers or software engineering researchers, if we look at public media accounts about security or about compromises about security or impacts of compromises, we kind of find two narratives out there. There are probably more, but these are the two that have kind of stuck in our minds. The first one is security should be handled through tooling. This came out a little bit in that little blurb, provocative statement I made at the beginning. Right? The tools are out there. We know how to fix this problem. And there is a narrative that says, and that's how it should be fixed, right? Through the tools. Right? The second narrative that we hear is that developers should be thinking about security all the time. And for me, when I picked up on these, I thought, well, hang on a minute, but if they're just supposed to be using the tools and using the tools the right way and using them consistently, why do they need to think about it? Can we be sure that they'll think about it? Right? So I just want to ask you guys about, I want to take a vote, okay? Let's do it in two pieces. So I want you to hold up your hand and tell me what you think about the first one. Who thinks security should be handled through tooling?
Sorry, is this either or?
Yeah, right now, let's do either or, and then maybe we'll do them both, okay? Who thinks security should be handled through tooling? So do it again, because do it again. Who thinks? Yeah, okay. Who thinks developers should be thinking about security all the time? Okay. We don't have to go into the details of what all the time means. During breakfast, brush your teeth, I don't know. And who thinks that both are true? You can hold it. Okay. Okay.
So it's interesting, when we asked the first question, very few hands rose, handled through tooling.
Yeah.
Second question, lots of hands rose, and the third, the combined question, a few more people's hand rose, although it wasn't as if it was because addition of two. People just felt, oh yes, the two are together important.
The two together are important. Okay. So, right now, I don't have a grand answer. I don't have a grand theory for how to solve the problem of security in developers. I'm actually still collecting data, and this was part of it. We're working on the project. It's called Motivating Jenny, and the way we are approaching this topic is to take an ethnographic approach. What does that mean? Somewhere I have it. Oh, hey, go back. Not yet. Okay. Somewhere I have it written down. Oh, okay. Ethnography. So what we do is we study people's actions and their accounts of actions. And the case that we worked through is one example of how we might do that. We're doing it on this project through field studies in offices. We're going in and working with developers, looking at developers, talking to developers. We're looking online to see how developers talk to each other in an environment, for example, like Stack Overflow. And then we're coming and we're trying to do some practitioner engagement to get a sense for the people who are working in some of these offices that we can't go and visit have to say about these topics. Ethnography is really, really useful for examining socio-technical environments. I think it's a really useful way to examine what technology means to us, how we're changed by technology, and in the context of developers, how developers can change and shape the technology that they're making. So some other hallmarks of the approach are that we examine what is done and why when we're going into these environments, and we take the individual perspective. So we're really interested in knowing what you think, what you think, what you think, what you think, all of you. Those, rather than looking at fields and coming up with some sort of model. Okay, so we're about, this is a 2-year project. We're about a little over halfway through. And these are some of the things that this ethnographic approach is showing to us. Some findings, some initial findings. And over here on the right, this is a card that we used at the workshop this summer. That sort of shows, how wide open this topic really is. But here's some other things that are coming out of some of the other work that we're doing. So what? Security and developers. What does this mean? Well, we're finding that developers are often users of security, right? In much the same way, or similar to the way that Stephen was in this project. But, for example, setting up SSH keys, or dealing with credentials on a network, access controls on a network. Developers often are dealing with security in those terms. Sometimes security is a barrier to practice. And developers seem to have different responses to what that means. Sometimes it's frustrating, sometimes it's something that they recognize as necessary and therefore they deal with it. Sometimes we see it as a barrier, but I'm not sure that it seems like such a barrier in their minds. It's just something that they have to deal with. When you ask developers about why they think security is important, they tell us that they view it as important for the company. They want to do well for their company, and they want to do well for the people, for the users of their tools, and also just the broader broader public. So I had another provocative statement at the beginning saying, developers we know what to do with security, but developers, they're not very effective. If they would just use the tools, this problem would go away. We are seeing evidence that developers do take responsibility for learning about security, quite a bit. They often tend to do it in small ways, though. Small ways that don't easily fit into an assessment about, for example, how the OWASP list is used. That's a complicated, the reasons for that we think are quite nuanced and complicated. We can't really go into them. But they are taking responsibility for learning about security. And they do it to different degrees. Some are really curious. They follow it on and on. They might not become specialists, but they maybe become the one who knows the most in their office. Other people become competent in security, right? They're interested enough to be competent. And others, it's interesting. I mean, how can you not be interested in security these days? It's everywhere, right? So they've got some interest in it, but maybe those are the ones that we would like to encourage more, right, to engage to a higher degree. We don't know. And then finally, developers really take it hard when something to do with security goes wrong. They take responsibility for it. They feel it. They feel bad. And, Stephen accounted for it. He came forward. There is a little bit of a coda to that tale. He is one of the founders of the company, right? So he had to take it personally. But I don't think that his account is uncommon. Certainly, it's in line with other research that I've done looking at human error in software development. Developers really do care. They care about security, and they feel bad when things go wrong. So, here's our project, Motivating Jenny to Write Secure Software, the Community and Culture of Code. You can follow us on Twitter. We tweet sometimes. Probably we should tweet more. But we put up some resources that we come across that look interesting to us. We put up some jokes, whatever we can find. Picture on the left is the lovely Professor Helen Sharp. She is the principal investigator for the project, and I am Tamara Lopez, and here are our email addresses. Please do get in touch with our project team. So we are two among many. We have some esteemed colleagues from Exeter and also at the Who's Jenny? Who is Jenny? That is a great question. We have, as I mentioned, we have a sister project which is called Johnny. What is it? What is the full name of it?
Why Johnny doesn't write secure code.
Why Johnny doesn't write secure code. It was funded by the EPSRC.
Yeah, and that's based on a well-known paper.
Right.
Which is talking about Johnny, where Johnny is a member of the public.
Right.
So that was a bit of a joke on that, and then we were sitting around saying, what should we call the project? And we thought, wouldn't it be funny to have one called Jenny or one called Johnny?
One called Johnny.
So it's as simple as that.
But for our purposes, it is a good question. Johnny, or Jenny, I'll get into the differences between Jenny and Johnny, oh my. Jenny is a non-specialist, a professional developer, probably working in a company, not necessarily working on a toy project at home, but a non-specialist. By non-specialist, we mean specialist in security. So they may be a hobbyist, yeah? They may be a novice when it comes to security. They may be starting to become really, really keen on it, but they're not trained as security specialists. They do not belong to a security department. Yes?
Do you find that, there's a different demographic, if you've got lots of people working in open source software, or you're working on embedded systems or build systems, your attitudes towards security changes?
Maybe. That's a good question. For this project, we're working in, I'll let Helen jump in too, but I'll start. Okay, we have field studies in 2 different organizations, and the group of programmers, the developers there are different. They're different kinds of programmers. They're working on different kinds of projects. The aims of the companies that they work for are different in terms of what they want to do with software. And maybe, I don't know if their training is different, but they're different. They have a different feel, both of these companies. And Yeah, I think once we're able to really dig into both environments, it might be possible for us to elicit different, different information about ways that they're different. But we're also at this early stage, we've just gone into the second category finding they talk about some things that are similar. And those are some of the things here. In both companies are relying on open source software. Right? In both companies, there are access controls that developers have to work around and with and within. Security is a barrier to practicing both. So right now we're seeing commonalities, but I'm sure as we go forward we will see something different. Did you want to add something to that?
Yeah, I mean, we're not studying open source or anything
Yeah.
like that, but in the past, I mean, the focus of the project is about motivation as well.
Yeah.
And the motivation for these different kinds of environments is quite different.
Yes.
Motivation theory for software engineering tells us that there's a link, as you'd expect, between potential performance for an individual and their actual performance, and that is actually mitigated by the work context. So the context, for example, is whether you're working with other people who are working on the same project or you're on your own. So in open source, you're sort of on your own, but you're not on your own. You've got a huge community of people around you. So I think that will affect the way people think about security and the way security is talked about within the community.
Yeah.
So again, as Tamara has said, our focus is on community and culture.
Yeah.
So we're coming at things from quite a different perspective than some people in the past have come to this kind of question. So I think, yes, it will make a difference, and I think the difference will come because of the different communities that sit around people. And one of the things we are doing is trying to characterise in some way the different journeys, as we call them. So there are different journeys, and when you start digging into it, of course, there's lots of different contexts that people are in when they're developing software. And so when you start going through all those different kinds of contexts and getting a feel for what effect that might have, then that's where we're trying to build up some other kinds of things.
Yeah. Yeah.
Complicated question.
Yeah.
Can I ask something?
Sure.
Oh, there is a couple of, okay, let me ask the last question.
In the companies that you're working with, have you noticed a difference in a company that's experienced a data breach or security incident as opposed to one that hasn't? So has the experience in living through a crisis made different attitudes?
I don't know if we have clear examples at the company level, but I do know that some of the people that we've talked to have different levels of personal experience with security. So somebody might run a server in their own time and have had some experience with a security incident in that context. Somebody might have been tasked with being in charge of security for a particular project in another company. So we are seeing differences there. And there is research that suggests that that can have an influence, right? That there is an influence from experience, having experience with security. Right now, that's kind of more the broader worker, looking at information security in organizations more generally, or individuals. Not necessarily specifically for software developers.
And I think one of the sorry, I can't see you around the corner. One of the companies we've been to that we're working with quite closely, they have actually had a vulnerability, but and I need to be very careful here. There is no evidence that we can see that it actually has made that much difference to the way the individuals react. I can't make a comment about whether the company has changed their policies or whatever. But
why that might be.
Or why that might be.
Why that might be.
Yeah, but I think it's there's a very kind of matter of fact and common sense. Probably common sense might be the way. Very matter of fact way. I think developers generally. I mean, developers want to develop good code.
Yeah.
They're very keen on high security. I mean, high quality. I mean, both of us have worked with developers for many years. I mean, this is our normal kind of way of working. Is that we go to companies, we spend time with in software teams. And people want to develop high quality code. So in a sense, security is just another one of those, in some respects. So I think what we're finding is not surprising, but people deal with it in a very matter of fact kind of way, I think.
But I'm not sure that we've had an example of somebody having a high profile individual case, right, where something that they did, as Stephen, had an impact on the company.
In the Q&A, you asked two questions. One was security should be handled through tooling or not. And developers should be thinking about security at all times or not. And it's an interesting one. I mean, I have experience from other paradigms. So through tooling, I don't know what is included and what is excluded, but I, for example, have worked with the criminal justice system, trying to understand how decisions are made and what are the consequences of decisions as they are made. So there could be judgments of courts, there could be things to do with probation, at what point people are set out on probation. And there is a suggestion there that humans are more fallible at the moment than the algorithms. If you have enough information, you are more likely to get the probation right using a machine than using a bunch of really typical people who sit on these probation boards. So that's point one. And point two, should developers be thinking about security all the time? Now, the obvious answer was yes, they should. But again, this is something, I've served on a number of boards, and I'm often given the task of serving as the equality, inclusion, fairness, diversity lead on board. Maybe it's my color, I don't know. But this is the point. First of all, when you talk about those four things, they are not the same thing. So sometimes, to be fair, you may need to be unequal to understand and empathize with the person's situation. So applying equal process doesn't amount to fairness very often. And then again, what do people mean by equality? Varies from organization to organization. So taking those two parallels, what are you including and excluding in tooling? Are you doing it all machine-based, where machine more or less keeps it right unless you are a superior human who can tell the machine how you are superior to the machine? And on the question two, what are the lower granularities of keeping security in mind?
Right. Okay. They're both good questions. So right now, I'm working in ethnography, so I waffle and I refuse to commit until the last possible moment because I want to keep having people like you raise these points. I think you're exactly right. Tooling can mean a lot of different things, and sometimes right now it has been established that certain security tools out there are very good, and if people would just use them, a lot of problems would go away. So that is true. And so the mystery is, why aren't people just doing that? It just seems so simple. So there must be something else going on. So we are kind of asking that question to be a little provocative and say, but when does tooling work? And how can it be integrated? And there are a lot of ideas out there about how to do it. There's the DevSecOps movement that you guys might be familiar with, which says those tools that we know work should be part of continuous integration. And if you put them there, then it will work. And developers just need to respond to the messages that they get from the security tools in the same way that they respond to the messages that they get about the build. Right? Maybe that will work. I think it's a little soon, right, to make a determination about when it will work. And maybe it will work, and this is what I suspect, some of the time, but not all of the time. And that will depend on the work context, the environment in which it's deployed and used. Okay. Developers should be thinking about security all the time. I liked the example that you gave, and I'd like to get those 4 notes, because we are hearing a taxonomy emerge from the developers that we work with about different kinds of security and how their attention needs to be paid to those different kinds of security. They don't see security as one thing, they see it as more than one thing. And they don't see their involvement with it as being the same thing either. They have a different idea about how they should interact with security, or uphold security, or think about security for these different types. But I don't want to show that. It's too soon. But thank you, that's great.